A very good morning, students. Today in Climatology, we'll be dealing with the monsoon. The term monsoon is derived from an Arabic word mausim or from the Mayan mausim, which means season. The word monsoon is applied to such circulation which reverses its direction every 6 months, that is, from summer to winter and vice versa. The term was first applied by Arab navigators to winds over Arabian Sea between Arab and India, which blows for 6 months from the northeast and for 6 months from the southwest. After going through this lesson, you will be able to understand the concept and origin of monsoon, Indian monsoon and other monsoons. Concepts of the origin of monsoon with focus on the Indian monsoon. The origin of monsoons is still shrouded in mystery. Several attempts have been made to explain the mechanism of monsoons, but no satisfactory explanation is available till date. Over the years, many mysteries of the monsoons have been unraveled, but still much remains to be done. The theories regarding the monsoons are generally divided into following two broad categories: classical theory and the modern theory. Classical theory. Although monsoons are mentioned in our old scriptures like Rig Veda and in the writings of several Greek and Buddhist scholars, the credit for the first scientific studies of the monsoon winds goes to the Arabs. Near about the 10th century, Al-Masudi, an Arab explorer from Baghdad, gave an account of the reversal of the ocean currents and the monsoon winds over the North Indian Ocean. Date of commencement of the monsoons at several places was reported by Sidi Ali in 1554 AD. In 1686, the famous Englishman Sir Edmund Halley explained the monsoon as resulting from thermal contrast between continents and oceans due to their differential heating. Accordingly, Halley conceived summer and winter monsoons depending upon the season. Summer monsoon. In summer, the sun shines vertically over the Tropic of Cancer, resulting in high temperature and low pressure in Central Asia, while the pressure is still sufficiently high over the Arabian Sea and Bay of Bengal. This induces airflow from the sea to land and brings heavy rainfall to India and her neighboring countries. Air mass theory. The southeast trade winds in the southern hemisphere and the northeast trade winds in the northern hemisphere meet each other near the equator. The meeting place of these winds is known as the intertropical convergence zone. Satellite imagery reveals that this is the region of ascending air, maximum clouds and heavy rainfall. The location of the ITCZ shifts north and south of the equator with the change of the season. In the summer season, the sun shines vertically over the Tropic of Cancer and the ITCZ shifts northwards. The southeast trade winds of the southern hemisphere cross the equator and start flowing from the southwest to the northeast direction under the influence of the Coriolis force. These displaced trade winds are called southwest monsoons when they blow over the Indian subcontinent. The front where the southwest monsoons meet the northeast trade winds is known as the monsoon front. In the month of July, the ITCZ shifts to 20 to 25 degree north latitude and is located in the Indo-Gangetic plain, and the southwest monsoons blow from Arabian Sea and the Bay of Bengal. The ITCZ in this position is often called the monsoon trough. H. Flohn of the German Weather Bureau, while rejecting the classical theory of the origin of monsoons, suggested that the tropical monsoon of tropical Asia is simply a modification of the planetary winds of the tropics. He thinks of the thermal low of northern India and the accompanying monsoon as simply an unusually great northward displacement of the northern intertropical convergence zone. The seasonal shift of the ITCZ has given the concept of Northern Intertropical Convergence Zone in summer and Southern Intertropical Convergence Zone in winter. The fact that the Northern Intertropical Zone is drawn to about 30-degree latitude may be associated with the unusually high temperature over North India. According to the interpretation, the main westerly current of the monsoon is simply the expanded equatorial westerlies which lie embedded in the great mass of tropical easterlies or the trade winds. The North Intertropical Convergence Zone is the zone of clouds and heavy rainfall. The next theory, the jet stream theory. Jet stream is a band of fast moving air from west to east, usually found in the middle latitudes in the upper troposphere at a height of about 12 kilometers. The wind speeds in the westerly jet stream are commonly 150 to 300 km per hour, with extreme values reaching 400 km per hour. Jet stream is the latest theory regarding the origin of the monsoons and has earned worldwide acclaim from the meteorologists. M.T. Yin in 1949, while discussing the origin of the monsoons, expressed the opinion that the burst of the monsoon depends upon the upper air circulation. The low latitude upper air trough shifts from the 90-degree east to 80-degree east longitude in response to the northward shift of the western jet stream in summer. The southern jet becomes active and heavy rainfall is caused by southwest monsoons. Yin's ideas are well recognized by Pierre Pedala-Broad in his book entitled The Monsoon. It shows that in winter the western jet stream flows along the southern slopes of Himalayas, but in the summer it shifts northwards, rather dramatically, and flows along the northern edge of the Tibetan Plateau. The periodic movements of the jet stream are often indicators of onset and subsequent withdrawal of the monsoon. The southwest monsoon in the southern Asia is overlain by strong upper easterlies with a pronounced jet at 100 to 200 millibar. These easterly winds, which often record speeds exceeding 100 knots, are known as the easterly jet stream of the tropics. The easterly jet stream was first inferred by P. Koteshwaram and P. R. Krishna in 1952 and aroused considerable interest among the tropical meteorologists. A careful study of the jets would suggest that the core of the easterly jet is at 13 kilometers while that of the westerly jet is at 9 kilometers. Over India, the axis of the strongest winds in the easterly jet may extend from the southern tip of the peninsula to about 20-degree north latitude. In this jet stream, wind speeds exceeding 100 knot may be recorded. There is a subtropical westerly jet to the north of the Himalayas besides the easterly jet over the peninsular India. The westerly jet stream is located along the southern slopes of the Himalayas in winter, but it suddenly shifts to the north with the onset of the monsoon. The periodic movements of the subtropical jet stream provide a useful indication of the onset and subsequent withdrawal of the monsoon. Recent observations have revealed that the intensity and the duration of heating of the Tibetan Plateau has a direct bearing on the amount of rainfall in India by the monsoons. When the summer temperature of the air over Tibet remains high for a sufficiently long time, it helps in strengthening the easterly jet and results in heavy rainfall in India. The easterly jet does not come into existence if the snow over the Tibetan Plateau does not melt. This hampers the occurrence of the rainfall in India. Therefore, any year of thick and widespread snow over Tibet will be followed by a year of weak monsoon and less rainfall. Thompson, Flawn and Stephenson have expressed more or less similar views, but Flawn's concept is widely accepted. These ideas can be explained by considering the winter and the summer conditions over large parts of Asia. The Indian monsoons, particularly the southwest monsoons, have generated a lot of interest among the meteorologists all over the world. Concerted efforts on data collection of intensive studies of monsoon regimes by various meteorological services and organizations from different nations have been made during the last 4 decades. Much has been done, but much more is yet to be done. The first attempt was done during the International Indian Ocean Expedition from 1962 to 1965. It was organized jointly by the International Council of Scientific Unions, Scientific Committee on the Ocean Research, and UNESCO with the World Meteorological Organization, joining the meteorology program. Special oceanographic and atmospheric studies were carried out with the aid of research vessels, instrumented aircrafts, rockets, as well as special upsonde and dropsonde surroundings. 2 more experiments were conducted jointly by India and the former USSR in 1973 and 1977 with limited participation from the other countries. These experiments are known as the Indo-Soviet Monsoon Experiment and the Monsoon 77 respectively. It was observed from these experiments that there is a specific zone off the coast of Kenya where the monsoons from the southern hemisphere cross the equator on their way to India. It was also observed that the fluctuations in the intensity of low level across the equator resulted in the fluctuations of rainfall over Maharashtra. Upper air observations over the Bay of Bengal were also made in 1977. More intensive data collection effort was made under the aegis of another international experiment, the Monsoon Experiment in 1979. It is popularly known as the MONEX 1979. It was organized jointly by the Global Atmospheric Research Program of the International Council of Scientific Unions and the World Meteorological Organization under their World Weather Watch program. It is so far the largest scientific effort made to extend the frontiers of our knowledge of the monsoons by the international scientific community. As many as 45 countries pooled their talents and resources under the aegis of United Nations for this great venture. The Great Monex was designed to have 3 components considering the seasonal characteristics of the monsoon. Winter Monex from 1st December 1978 to 5th March 1979 to cover the eastern Indian Ocean and the Pacific along with the land areas adjoining Malaysia and Indonesia. Second, the Summer Monex from 1st May to 31st August 1979 covering the eastern coast of Africa, the Arabian Sea and the Bay of Bengal along with the adjacent landmasses. It also covered the Indian Ocean between 10 degree north to 10 degree south latitudes. A West African monsoon experiment over western and central parts of Africa from 1st May to 31st August 1979. A strong anticyclone developed in the Arabian Sea in the summer of 1979. Therefore, 1979 was not a normal monsoon year and the MONEX failed to study the normal behavior of the monsoons. But the vagaries of the monsoon are proverbial, and in a scientific and analytical understanding of the monsoons, a study of anomalies is perhaps more important. It is in this context that the MONEX 1979 assumes unparalleled significance. Teleconnections, the Southern Oscillation and the El Niño. Recent studies have revealed that there seems to be a link between the meteorological events which are separated by long distances and large intervals of time. They are called meteorological teleconnections. A study of the last 100 years of the Indian monsoons shows that out of 43 deficit monsoon years, 19 were associated with the El Niño. On the other hand, there were 6 El Niño years which were also the years of good monsoon rain. Thus, although there is a tendency for poor monsoons to be associated with an El Niño, there is no one-to-one correspondence. We have covered these topics in detail in the other chapter with detailed focus on these anomalies. After the severe drought of 1987, parametric and power regression models have been developed to forecast monsoon rainfall by utilizing signals from 15 parameters. Some of the parameters are global while the others are regional. These parameters are divided into 4 broad categories with the temperature, pressure, wind pattern, snow cover. Temperature related parameters include El Niño in the current year, El Niño in the previous year, northern India, east coast of India, Central India, Northern Hemisphere. And the wind related parameters include 500 hectopascal equals 1 millibar ridge, 50 hectopascal ridge trough extent from Jan to February, 10 hectopascal 30 kilometers westerly wind in January. Pressure anomalies include the Tahiti Darwin Spring, and the South America, Argentina in April, and the Indian Ocean equatorial region from Jan to May is observed. The snow covered related parameters include Himalayan region from Jan to March, Eurasian region from the previous December. It was observed in the late 80s that whenever more than 50% parameters showed favorable signals, the monsoon rainfall in India was normal, and when 70% or more parameters were favorable, the monsoon rainfall was above normal. Somewhat similar set of predictors for monsoon was suggested by H.N. Srivastava and S.S. Singh in 1994 while discussing long-range weather forecasting techniques. One more parameter was the surface pressure anomaly of the northeastern hemisphere was also added later on, thus making a total of 16 parameters. These 16 parameters have been used by the IMD to develop the power regression model. Although the model has been accurately forecasting rainfall in India since 1989, it has been far from being an elaborate and foolproof model. A model capable of forecasting area-specific rainfall is yet to be built. The study of the data following the Monex, TOGA and other experiments is continuing, and our meteorologists are hopeful of discovering more parameters which may help in developing better models capable of predicting rainfall more accurately. Distribution of the monsoon. A monsoon is a seasonal change in the direction of prevailing or the strongest winds of a region. Monsoons cause wet and dry seasons throughout much of the tropics. Monsoons are most often associated with the Indian Ocean. Monsoons always blow from cold to warm regions. The summer monsoon and the winter monsoon determine the climate for most of India and Southeast Asia. Summer monsoon. The summer monsoon is associated with heavy rainfall. It usually happens between April and September. As winter ends, warm, moist air from the southwest Indian Ocean blows towards the countries like India, Sri Lanka, Bangladesh, and Myanmar. The summer monsoon brings a humid climate and torrential rainfall to these areas. India and the Southeast Asia depend on the summer monsoon. Agriculture, for example, relies on the yearly rain. Many areas in these countries do not have large irrigation systems surrounding lakes, rivers, or snowmelt areas. Aquifers or supplies of underground water are shallow. The summer monsoon fills the wells and aquifers for the rest of the year. Rice and tea are some crops that rely on the summer monsoon. Dairy farms, which help make India the largest milk producer in the world, also depend on the monsoon rains to keep cows healthy and well fed. Industry in India and the Southeast Asia also relies on the summer monsoon. A great deal of electricity in the region is produced by hydroelectric power plants, which are driven by water collected during the monsoons. Electricity powers hospitals, schools, and businesses that help the economies of these areas develop. When the summer monsoon is late or weak, the region's economy suffers. Fewer people can grow their food, and large agro businesses do not have produce to sell. Governments must import food. Electricity becomes more expensive, sometimes limiting the development to large businesses and wealthy individuals. The summer monsoon has been called India's true finance minister. Heavy summer monsoons can cause great damage. Residents of such urban areas as Mumbai, India are used to the streets flooding with almost half a meter of water every summer. However, when the summer monsoon is stronger than expected, floods can devastate the region. In cities like Mumbai, entire neighborhoods can be drowned. In rural areas, mudslides can bury villages and destroy crops. In 2005, a strong monsoon devastated Western India. As the summer monsoon blew in from the southwest, it first hit the state of Gujarat. More than 100 people died. Then the monsoon rains hit the state of Maharashtra. Flooding in Maharashtra killed more than 1,000 people. On July 26, 2005, the city of Mumbai, Maharashtra received 39.1 inch of rain. Now we move on to the winter monsoon. The Indian Ocean's winter monsoon, which lasts from October to April, is less well known than its rainy summer equivalent. The dry winter monsoon blows from the northeast. These winds start in the air above Mongolia and the northwestern China. Winter monsoons are less powerful than the summer monsoons in the Southeast Asia, in part because the Himalayan mountains prevent much of the wind and moisture of the monsoons from reaching the coast. The Himalayas also prevent much of the cool air from reaching places like southern India and Sri Lanka, keeping them warm all year. Winter monsoons are sometimes associated with droughts. Not all winter monsoons are dry. However, unlike the western part of the Southeast Asia, the eastern Pacific coast of the Southeast Asia experiences its rainy season in the winter. The winter monsoon brings moist air from the South China Sea to areas like Indonesia and Malaysia. Now let's talk about other monsoons in other parts of the world. The Asian-Australian monsoon, which includes the Indian Ocean, stretches from northern Australia to Russia's Pacific coast. This huge monsoon wind system then stretches into the Indian Ocean. Finally, it reaches its end on the Indian coast of Africa. Monsoon winds exist in the other parts of the world too. The North American monsoon happens once a year, usually in the middle of summer. Warm, moist air from the Gulf of California blows northeast, while the warm, moist air from the Gulf of Mexico blows northwest. These two winds meet over the Sierra Madre Occidental Mountains in the central Mexico. The monsoon brings moisture to the mountain ecosystem before continuing north to the US states of Arizona, New Mexico, and Texas. Summary. Because of a seasonal reversal in the wind direction, areas with the monsoon type of climate experience different air masses in different seasons. Naturally, this has important effects on the precipitation and the temperatures of the monsoon regions. Most of these regions have wet summer and dry winter. The economic significance of the monsoons is enormous. This is born out of the fact that a population of more than 2,000 million lives in the area which has got monsoon type of climate. Roughly, about half the world's population depends on the monsoon rains for their crops. It is primarily because of the great economic significance of the monsoons that the Asian summer monsoon in particular has been given more importance.